I would the topic design approaches and causes of failure. And
Fortunately, you actually have to hold this up.
every engineer knows this table. That's what main design approaches. If you have competent bedrock, we do not care about permafrost. But if frozen soil is not acceptable, there are two methods, so-called passive method, maintain frozen state of soil, and active method to accommodate changes or modify foundation soils. The case is to consider permafrost is ice poor. It is not thus acceptable, conventional for the temperature zone approach. Permafrost stowing under structure during its service time with the ability of structure to adapt consequences of the settlement. Permafrost state should be maintained through the entire life of structures or modification of permafrost before construction, such as replacement of ice-rich soil or pre-thawing of soil with its compaction before construction. How to decide? There are so-called collapsible soil losses in hot regions, and permafrost is one of them. If you put load on permafrost practically doesn't change, but if you add heat, permafrost soil collapse. That's what collapsible soil. And ASTM has a classification to relate permafrost collapsibility. This is the percent of the settlement of the total thawing depth. 0, of course, no problems. 1% to 5% moderate problems, 5 to 10% troubles, 10 to 20% severe troubles, and more than 20% very severe troubles. That's what we can decide what kind of approach we can take first step. This is some data from Canadian, western part Canadian, and from some data from our research. And we can see that no to slide problems is very small part of permafrost soils. And we can expect that in most of cases, we were in regions of very severe problems if we allow permafrost to thaw. There are numerous causes of failure, but they can be summarized as insufficient geotechnical information, mistakes in design, construction deficiency, and poor maintenance. And I give you some examples of each one. The simple example from Dr. Peve, this is Presbyterian Church on College Road. It was built many years ago. It's something close to DHGS and Beaversport. And beautiful log building on College Road, this church, you can see it maybe, I don't know, 50 years, maybe older. But there was a church school building behind the church. There is no even traces of this one, because look at this one. The condition changed in the hundreds of, less than maybe hundreds of feet. We have on one side on the church, we have riverbed deposit, and we have slough deposit under church building with ice wedges and so on. And of course, there wasn't information, and everyone, if try to find the geotechnical information, first of all, look for the main building, church building, and kind of spread this information on the entire land. That's what kind of example of the insufficient geotechnical information during construction. Mistakes in design. Mistakes in design can be local for each project, but it could be worst case scenario if it's wrong approach among the design community. In 1930s, the founder of Russian permafrost science, Professor Sungin, analyzed one deep thermal data from one deep boreholes, and came to conclusions that this is a degradational type of permafrost, the degradational type of thermal curve. And he spread this permafrost degradation theory all around the permafrost region. It's not wrong, but engineers, he was the, if not God, but at least Moses of Russian permafrost at the time. Engineers decided, okay, if permafrost is degrading, let's resist to permafrost degradation. And they try to build very strong structures to resist permafrost degradation. But we've seen that permafrost would be, settlement would be really huge, and all buildings were designed, for example, in Vorkuta regions or Chita regions, failed. And after the Second World War, they started to build this permafrost protection. That's what was a big mistake. Construction faults. Duane Miller described failure which occurred at the village of Silavik. The building was supported on 6 piles, 3 of each side, not a big one. And there was a ventilated crawl space beneath the building. And it was a pile foundations with pre-drill holes with a slurry. But if you look any classification for or requirements for slurry, it's usually said that water temperature or slurry temperature which you put in a hole between pile and permafrost, it should be for some Russian, for example, 10 degrees Celsius. Alaska pipe oil company a little less, but it should be definitely warm slurry. You have time to compact it and so on. But in this case, they used frozen cutting from drilling, and they took water from the hole in the ice in the river, and they 42-degree water, and they put cuttings first and try to pour water on these cuttings in the hole. And of course, there was winter and cold cuttings, cold permafrost, and water frozen freeze in the upper part of the hole. In the spring, this slurry on the top of this started to flow, but there wasn't support slurry at bigger depths, and the building start to settle just in the first spring. And it was a big effort to fix it. No equipment on the site, no way to drill new holes and put new piles. And they just saw slurry in the hole and compacted it and added the new one. This is the example of small example of the construction fault. Following examples of failure due to poor maintenance are from Norilsk, Russia. Norilsk is a fantastic city. It's maybe the most sophisticated city in Arctic. When I visited it in the end of 60s and 70s, from the other side of the Russian Arctic, you look like you came to you feel like you came to paradise. And this construction of this city brought a lot of innovation to Arctic engineering, and everything was for a while okay. Before I go further, I talk about impact of ventilated crawl space. Ventilated crawl space is amazing features for permafrost. If you look at data, for example, on the left side from the Norilsk, you see when they build the structure, permafrost temperature was with one building -2, for another -3 Celsius. In 8 years after construction, temperature change in 3-4 degrees. if you have, and the other example from Yakutsk, and you can see the burning capacity during this during the structure's life, definitely is. I believe in first case in Norilsk, maybe burning capacity increased several times. Even more interesting example, it's from Nadim. And permafrost, the design was, during the design, permafrost temperature expected minus 0.7 Celsius. After several years, permafrost temperature decreased in 4 to 5 degrees. Definitely, this is huge factor of permafrost protection, but it works only if we definitely maintain well ventilated crawl space. When I was in Norilsk, I believe in 1972, I have seen these pictures. This is the sign of the, that man won over permafrost. Permafrost is converted. And on the right side, they put these snowflakes. It's, again, this is the sign of the permafrost in convert. I'm superstitious person. I don't like this stuff. I'm afraid to, to ask for trouble when you start to talk like this. And it was happened in some buildings in mainly in 1990s and beginning of 20s. And again, you can see somebody put sign, permafrost is not forever, the life is forever. What's happened? There are two main reasons. This is permafrost is kind of permeable in Norilsk, and leaking of utilities, it's killing for permafrost. First of all, you know what's happened in Russia in 1990s. The Russian overnight turned from one economical system to another, from socialism to capitalism. And during socialism time, in Norilsk, everything belongs to the factory, the biggest factory of precious metals in the world. Everything was, they took care about everything, but ownership changed, and practically during 10 or even a little more years, nobody cared about what is going on with permafrost underbuilding. The permafrost laboratory was closed, and nobody took care about permafrost underbuilding, leaking utilities. And you can see on the left side up, if permafrost is permeable, you even cannot see leaking, notice leaking in the summertime. But in the wintertime, you can see all these huge ice bodies. Second one, there was a local war in Russia in 1990s, and there was some terrorist attacks, and they were afraid of terrorist attacks. And in Norilsk, and where the terrorists should hide, definitely in their crawl space, and they nailed all crawl spaces for a couple of years. Practically, no ventilation. Finally, they opened it. The other one, they had shortage in heating oil, and in Russia, there is no local heating for every building. It's centralized heating stations, and they were short of heating oil, and they decided they were afraid to freeze entire the system, and they just discharge all water on the ground. This is what example of one of the worst accidents related to permafrost degradation. This is Talnakh satellite of Norilsk. It was the kind of one of the most valuable places in Talnakh. People like this restaurant. I enjoyed good food there several times in 68, 72, and 73. And what's happened in 1976, on July 12, this building collapsed, and building was full of people, and collapsed, and about 9 to 19, nobody knows exactly how many people were. The information was suppressed, and that time there was no even word, even one word on any media. Nobody, kind of people pick up information from foreign radio station like Voice of America. And it was interesting. There, about a couple of weeks later, there was a small article in newspaper, Save the White Deers. And people were curious what is it about, but the paper was not about the restaurant White Deer, but it is about several migrating white deers who were in the town, and they were afraid that they would be killed by traffic. The other problem, it's blockage of ventilated crawl space. Now in Norilsk, they started to snow removal around buildings. You can see with this huge snow drift, you cannot, the ventilation is blocked in the winter, but the ventilated crawl space utilizes winter resources, not summers. So the other problem in especially in coastal areas is saline soil, and this saline soil creates extra problems. In for example, there's a problem in Bera. Again, it was described in the literature that when they built state courthouse in 1984, the settlement occurs practically very soon after construction. Under one part of the building was happened during the geotechnical investigation. There was not found that there is a package of brain, very saline soil under one part of the building. And salt content definitely should be considered in design of pile foundation and permafrost, and bearing capacity of frozen soil greatly affected by salinity. And of course, if it's brine, soil is not frozen. If you design for it freeze, definitely everything could be, went in wrong direction. These examples from Russian Arctic failures due to saline permafrost. So far, from my point of view and some of my colleagues, the impact of the climate change, we should consider impact of the climate change and man-made factor. And so far, looks like man-made factors prevail over climate change. And of course, climate change is real. It should be considered in design. And the worst case is combination of the climate change impact and man-made effect. And the climate change should not be an excuse for our mistake and negligence. If we consider two factors, climate change and man-made impact, of course, climate change is global, regional, regional, and man-made factor, local or community level, or at least become maybe regional in some catastrophic cases, mainly related to oil spills, for example, like it was several years ago in Norilsk region or in Komi 20 years ago. But definitely we should consider climate change. When we look, many years ago, when I talked to one of my friends, who studied ice wedges, and I said, if you want to really understand ice wedges formation and development and so on, put yourself on a place of the ice wedge. Try to feel what ice wedge feels. And set this impact of climate change and man-made impact on permafrost. If you look from the point of view to climate change, okay, permafrost in a tundra, for example, permafrost says, okay, it's getting warmer. But if you develop and put, for example, asphalt road over permafrost, for permafrost doesn't know you put asphalt road. Permafrost understands that temperature just jump. You know, the climate, the local factor, climate changes is steady and regional and global factors. Local impact, huge impact on permafrost at specific places. If we take, as example, Fairbanks, we still have lots of permafrost around Fairbanks. But in developed area, permafrost is gone, and gone many years ago. We should definitely, when we start to talk about mitigation, we should first of all clean our wrongdoing. And if we do it, we can easily mitigate climate change. But again, the worst case scenario, when we have climate change, multiply by impact climate change, multiply by our mistakes and our, thank you.